This is section 8.1, Introduction to Functions. The objectives for this section is to find the domain and the range of a relation, determine whether a relation is a function, and evaluate a function. First of all, we got to talk about what a relation is just a set of numbers or values. And there are ways here to find in a relation the domain and the range. So a relation is a set of numbers that are organized in a certain way. And the steps are, the domain is the x value of the function, and the range is the y value of the function. So let's look at the example 1. It says, find the domain and the range of the given functions. So all the x's are 1, 2, 3, and 4, and that is the domain of our function. So how we write it is you do a capital D, then a colon, and you do these little fancy brackets, and I'm not going to be very good with it on here, but they look something like that. And you would write the 1, 2, 3, and 4 with a comma in between each one. 1, 2, 3, and 4, and you close the fancy bracket. That's the domain. There are all the x values. The range, use an R with a colon, fancy bracket, and you've got 5, 5, 7, and 8 for your y values. Range is y. You do not repeat the numbers, so you're only going to write down the 5 once. So you've got 5, 7, and 8. That's all there is for domain and range. Try the checkpoint. Press pause here when you get done with the checkpoint. Unpause, and I'll give you the answer. Alright, so checkpoint 1. Find the domain and range of the given functions. You got the domain, and that's not a very good bracket. Not getting any better. You got 1, 2, 3, and 4 again. And the range, you've got 5, 55, 27, and 18. 55, 27, 18. Make my 8 a little better. And a terrible squiggly bracket again. You can make them better on pen and paper, and I can show you on the board when we get to class. So that's domain and range checkpoint. Let's move on. Determine whether a relation is a function. So now we're looking at these ordered pairs of numbers, and we want to see if they're a function or not. And this says, the definition here says a relation is a function when there is one and only one y value for any given x value. So that's the technical definition. The easiest way to do these problems, you could say, another way of saying this is the x can't repeat. If the x repeats, then it's going to have two different y values. And if that happens, then it is not a function. So let's look at example 1. And we have these bubbles here to do the problem, help us do the problem. We're going to write down, on this side, we are going to write down the x values. And on the other side, we're going to write down the y values. they're also called f of x, which is the same as y. Y and f of x are the same thing. So we're going to write them down in a column. For x, we got 1, 2, 3, and 4 again. And for y, we've got the 5, 7, and 8. 5, 7, and 8. Alright, so we're just going to match up the ordered pairs. 1 goes with 5, so we're going to draw an arrow. And 2 goes with 5. So 2 numbers go to the same y, that's okay. They're 2 different x's. 3 goes to 7, and 4 goes to 8. If that makes everything fine, it doesn't have, the x doesn't repeat, and so we have each x has 1 y, so it is a function. Each x has 1 y, so it is a function. That's the definition for a function. Again, you're just looking for, does the x repeat? You can look at b here. You can see we got 5, 5, 7, and 8. We can see already that we've got 2 x's that are 5s. If that happens, this thing's not going to be a function. And I'll show you what happens when we stack them up. You're going to have, for your x, you're going to have 5, 7, and 8. And for your f of x, you have 1, 2, 3, and 4. And so we can see that 5 goes with 1, but 5 also goes with 2. And we got 7 and 3 and 8 and 4. And this is not a function because 5 has 2 different y values. So we have 1x with 2 different y values. That makes it not a function. Not a function. Because 5 has 2 y values. Okay, namely 1 and 2, but we don't have to write that out. So it's not a function. Basically, you can see if the x's repeat, we've got the 5 there twice in the x position, it's not going to be a function. Pause here, try checkpoint 2. When you come back, I will give you the answers. Okay, so here are the answers for checkpoint 2. You've got 1, 2, and 3, and 15, 17, and 8. 1 goes with 15, 2 goes with 15, 3 goes with 17, and 3 goes with 8. And because 3 repeats and 3 has 2 different y's, it is not a function. B, we got 21. Oh, sorry. These are x's. And this is f of x. This is x. F of x. And remember, f of x is just another fancy way to say y. 21, 22, 3, and 4 are y values, or f of x are 5, 7, and 8. So 21 goes with 5, 22 goes with 5, 3 goes with 7, 4 goes with 8. All the x values, I'm sorry, we don't have 2 different y's for one x, so this is a function. And again, you can see the x values, they don't repeat. 22, 21, 3, and 7, if they don't repeat, it's not going to be a function. Let's look at evaluating a function. example 3. And I do want to change this example. I want you to change this example in your homework. Make this f of x equals, instead of x plus 5, make it 3x plus 5. That way it'll be more like your checkpoint. You'll be able to do checkpoint. And so what this is asking us to do, it says find f of 0. And since 0 is in the x position, so here's f of x, and we plugged in a 0 for x. What that means is just plug in a 0 for the x in the problem. So we're going to plug in a 0 for this x right here. And so we would have 3 times 0 plus 5. 3 times 0 is 0. 0 plus 5 is just 5. And that's f of 0. So we'd say f of 0 equals 5. F of 2, we're going to plug in the 2 for x. So it would be 3 times 2 plus 5. That'll make a better 2. 3 times 2 plus 5. 3 times 2 is 6. 6 plus 5 is 11. So f of 2 is 11. And f of 2y, we're now plugging in the 2y for x. So it's going to be 3 times 2y plus 5. And this one we got to simplify. F of 2y is going to be 3 times 2 is 6y plus 5. Go to the next page. I'll pause here, try the checkpoint, and I'll give you the answers. Okay, F1 for your checkpoint. The answer to F1 is 7. The answer to F4 is 16. And the answer to F of 4W is 12W plus 4. Let's look at example 4. We're going to be using function notation. And it says function f is defined by the following table. And you have x and f of x. And remember, that's x and y. F of x is just y. And we have these numbers for x and these numbers for f of x. And it says explain why the table defines a function. So it's telling you it is a function. We want to know why. And the reason why, it's the same reason, it's always the same reason why. It's basically the definition that there is only one y value for any x. So A, I'll write it over here on the side. Actually, I write it on bottom. Forget about that. A, there is only one y value for any x. That is the reason why it is a function. And you can see none of the x's repeat. Negative 2, negative 1, 0, 1, and 2. None of the x's repeat, so it is a function. And there's being one y value for any x, that is the reason why. Let's look at B. Find the domain and the range of the function. Okay, domain. Domain is all the x values. You've got negative 2, negative 1, 0, 1, and 2. That's your domain. Your range is 5, 0, 3, 1, and 4. And again, the brackets, I apologize for those. They're horrible. But this pen does not make it easy to make those brackets. I'm not very good at them anyways. For part C, D, and E, we got to find the function's value at f of 1. Okay, so, or f of negative 1, I'm sorry. F of negative 1. You could see that we have a negative 1 plugged in where the x would normally be for f of x. So normally we have f of x and we have negative 1 plugged in. So negative 1 is your x. So we'd look over here at the negative 1, that's our x, and we need to read the value of that function at negative 1. It's going to be 0. So f of negative 1 is 0. We're going to do the same thing for d. F of 0. We're looking at 0 for the x now. Its value is 3. So f of 0 equals 3. And e is a little different. It says find x such that f of x equals 4. So now we're not given the x, we're kind of given the answer. We're told what f of x equals. And f of x is y. So we're told of y equals 4. Well, y equals 4 right there, and they want the value of x that gives the y of 4. That is going backwards. That gives 2. So you'd say f of 2 equals 4. So x equals 2. Stop here. Try the checkpoints. When you come back, I'll give you the answer. Okay, checkpoint 4 right here. I'm going to use these lines to write on. Try to. A, again, the reason why the table defines a function, it's because all the x values, 0, 1, 2, 3, 4, they don't repeat, and so we get that there is only one y value for any x. B, the domain and range. Domain is just all the x's. You got 0, 1, 2, 3, and 4. Let me try to remake my 2 here. And I'll try my best for that squiggly. It's not very good. And the range is 3, 0, 1, and 2. You can put them in order. 0, 1, 2, and 3. If you didn't, that's okay. Just don't repeat the 3. You only write down the 3 one time. So 0, 1, 2, and 3 is the range. C, you got g of 1. G of 1 is 0. D, g of 3. That is 2. And E, g of 4 is what equals 3. So x equals 4. That's all for this section. I will give you your homework tomorrow. Thank you.